Today it's digital electronics. We'll be learning about a few questions. What sort of models can be expected in digital electronics? Considered to be an easy subject, no doubt, but the sort of questions, typical questions that you can expect, sometimes can be confusing that you cannot answer them that easily with just English or just vocabulary. You need some equations, some diagrams. So let's see how you handle digital electronics questions. Let's see what sort of questions can be expected. Look at the first question. There is a number called as 20 in octal and also in hexa. So 20 in octal, 20 in hexa. Which one is considered to be large? Which is expectedly large? How do you resolve it? Is 20 in octal greater than 20 in hexa, or 20 in octal less than, or which one do you think? One of the easiest ways is converting it to binary. And the moment you convert it into binary, I think obviously you'll get its decimal equivalent. So that way you can get it. But what I feel is it's more easy even if you directly convert it into decimal. Because if you watch carefully, 20 in octal is what? 8 power 1 into 2 plus 8 power 0 into 0, which is just nothing but 16 in decimal. So 20 in octal is 16 in decimal, whereas the same 20 in hexa is 16 power 1 into 2 plus 16 power 0 into 0, which should give you 32 in decimal. So clearly 32 in decimal is greater than 16 in decimal. So since the base is larger and the number being same, since the base is larger and the number being same and it's a 2-digit number, 20 in hexa is obviously greater than it. You can also get the same equivalent by converting this 20 in octal as 0, 0, 0 and 0, 1, 0. So if you look at 20 in octal, 0's equivalent in 3 bits is 0. 2's equivalent in 3 bit is 0, 1, 0, 0. Whereas the same 20 in hexa is 4 zeros of hexa being 4 zeros of 0, and this is 0, 0, 1, 0. So very clearly you can see 1 is in the 5th position here in octal, whereas in hexa 1 is in the 6th position, making it exactly double, making it exactly increase by 2 times. So that is a common sense you can use, that when you convert octal into binary, each digit you have to convert into 3 digits of binary. So just convert octal into binary very easily. How? 0's 3-digit equivalent, 2's 3-digit equivalent. Similarly, 20 in hexa, when you convert it to binary, 0's 4-digit equivalent, 2's 4-digit equivalent. So that's quite easy. So this should obviously give you 16, because 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4. This should give you 32 because it's 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5. 2 power 5 is 32. So very clearly 20 in hexa is greater than 20 in octal. That's how you can answer it when they ask you to compare. It's a very simple question, maybe the first question to begin with. So let's go with the better questions. What is a flash memory? Is it a RAM or ROM? What sort of memory is flash memory? Flash memory is clearly a RAM and it is very fast in execution. What makes it very fast in execution? Because it reads and writes blocks rather than bits. That means an entire block is erased completely or an entire block is written rather than writing in bits 1 by 1, 1, 0, 1, 0, 1, 0. So makes it very, very fast, and it's a non-volatile memory. Being a RAM, it's a non-volatile. So makes it very fast to access. very fast to execute. That's what is called as flash memory. What is a ring counter? A normal counter counts a set of events within a clock pulse. How many events have occurred within a clock pulse? Like suppose I want to count the number of times I should ring the bell. I have to ring the bell exactly for every 1 hour. Like I have set a timer for a device. So I need to count frequently. A ring counter is one such counter, but the difference is the last flip-flops output, because counter is made out of flip-flops. So counter is used to count and sync with the clock. Now it is a combination of flip-flops. That last flip-flop output is connected back to the first. That's what is called as a ring counter. So that it is easy to set reset, to reset your counter. So what is a ring counter? It's nothing but where the last flip-flop is connected back to the first one. And there will be n flip-flops. Then there will be 2n minus n states. 2 into n minus 1 states. That's what makes a ring counter. Now what's a Johnson counter then? A Johnson counter is also a ring counter, except that the last state's output is complemented and then connected to the first. So the last flip-flop's output is complemented and connected to the first. That's the difference between ring counter and Johnson counter. This complementing or not complementing is only to increase the number of unused states or increase the number of used states. Because for n flip-flops, you should try to have maximum states in it, maximum levels in it, maximum counting in it. So to increase the number of used states or to increase the number of count with a minimum flip-flops, we go for this operation. So if somebody asks you what is the advantage of ring counter or the Johnson counter, the answer is simple. You can increase the count size with minimum number of flip-flops. So that's what is called as Johnson counter. What is lockout condition then? Lockout condition in counters, what does it mean? Because every counter has got some unused states and there are some desired states, wanted states. So desired states in counters are used for counting events, whereas the counter has also some unused states which it has to come back to frequently to the used states from these unused states. So whenever a counter is going to the unused states, it has to come back to the used states. But suppose if consecutively it's going to two unused states, two consecutive states are unused, then it is said to be in lockout state. So lockout state is a situation where the counter is taking two consecutive unused states. Instead of getting back to the used states, it's going next to the unused states. That's called as lockout situation. Next, why is gray code called as minimum change code? What makes gray code interesting? Gray code is called as minimum change code because between two consecutive decimal equivalents, when you look at decimal 8 and decimal 9 or decimal 14 and decimal 15, so when you increment a decimal number in the next gray code, the number changes only by single bit. So between 8 and 9, there is only single bit change. In binary, you don't expect it. Like if you look at between binary 7 and binary 8, almost all the bits will change. Binary 7 and binary 8. But when you look at binary 8 and 9, maybe only one will change. But in gray code, between any two consecutive integers, consecutive decimal numbers, if you look at their binary equivalent, there is only one bit change. When we increment a decimal number in the next gray code, only one single bit will change. That's why it's called as minimum change code. What is the difference between a flip-flop and a latch? Something interesting. Flip-flop and latch are almost identical. Both have binary binary states, set and reset states or 1 and 0. And they both change their state depending on the input. They both have two stable states. Both are two stable bistable devices. The major difference is in the triggering. When you want to go from set to reset or 1 to 0, the flip-flop will be triggering on the edge at the end of the pulse. So when the pulse is just being completed, flip-flop will be changing its state. whereas a latch will be changing its state during the running of the pulse. The triggering is at the level state. That means if this is the input clock, flip-flop will be changing its state exactly here. That's called as edge triggering. Whereas latch will be changing its state anywhere here. So it won't be occurring at this edge when the transition is occurring. It will be occurring when this is going on. Otherwise, similarly, one more difference is there. Flip-flop has a synchronization clock. Latch doesn't need a clock. That's why latch, the triggering is not at one point. It can be anywhere during this level. So latch, there is no clock. There is no perfect synchronization for the trigger. It may occur here, it may occur here, it may occur here. Whereas flip-flops occurs exactly here. That is a major difference. Very favorite question for examiners. Which flip-flop is called as universal flip-flop? Universal flip-flop is obviously JK flip-flop, because any other flip-flop can be obtained from this JK flip-flop. SR, master slave, anything you can obtain from it. Anything can be constructed from it. Just like universal gates, NAND and NOR. Similarly, universal flip-flop is JK flip-flop. All other flip-flops are some other modification of it. What is a clock skew? Clock delay, clock skew. A clock skew is nothing but where there is a delay in the clock pulse between various components in the same circuit. So that it's some sort of a jitter that's coming between different elements. It could be a delay in a few nanoseconds, but the timing pulses at the clocks of various components which come from the same trigger, they're being delayed. That's what is called as skew. So the disadvantage of this is the major cause of this. What could be the cause of it? The cause is nothing but the length of the transmission line, or the losses in the transmission line, or the losses in the connections, because there are multiple connections in between. So every signal travels at the speed of light. In spite of traveling at the speed of light, there can be small delays because of losses. That is something that causes skew. So skew is nothing but the delay in the timing pulses between various components which use the same clock. They're all using the same clock, but there is a delay between them. Next, what is a finite state machine? And what is the difference between the Murray state machine and Mealy? Murray and Mealy, what could be the difference? But first of all, what is a finite state machine? A finite state machine is unlike a flip-flop which has two states. This can have multiple states. It can send multiple outputs, multiple symbols. So flip-flop has got only 1 and 0 state. A finite state machine can have 0, 0 state, 1, 1 state, 0, 1 state, 1, 0 state, and so on. So there are chances of multiple states, which are examples of 4 states here. ABCD states. So the common sense is this. Whenever you feel there are chances of multiple states or finite states, the output can take any of these values. We call it as a finite state machine, which is typically used for automation, industry automation. Now, what is a Mealy SM then? Mealy SM is something where the output presently, the present output depends on the present inputs as well as the states of the flip-flop. Even the previous states of the flip-flop also decide your present output. So there is a memory unit or the previous states and the present states which combinedly decide what output you are supposed to get. Then what is Murray then? Murray is where the output is purely depending on the flip-flop memory states. And these flip-flop memory states of course may depend on the inputs, no doubt. But still, the output depends purely upon the present memory states, not just on the inputs. Nothing to do much with the inputs. It only depends on the state of the memory now. Whereas Mealy is something where the output depends on input plus memory states. That's the difference. So more such questions will come out. More such details will come out. And we are not telling you how exactly you should tell in the interview. In the interview, you may have your own style. your own approach, your own words. But this is how you're supposed to express. This is how you're supposed to put your point. Maybe in the exam, in the actual interview, you may not have a block diagram like this to explain. So you can directly say, sir, can I show a block? Can I write something? So technical interview is not necessary that everything should be as it is from what the teacher is teaching. It can be your own implementation, your own execution. So see you with more questions in digital. That's again a continuation for digital. See you in the next video.